Answer without drawing the pictures. You got to start with, and I want you to start with the concrete, real things here. The first thing you were doing was saying 3 divided by 1/2, not divided in half, right? Divided by a half means how many of these things fit into this. That's where the picture helps you understand what the answer is going to be. If you draw 3 rectangles to represent the 3, to represent this, here's my 3 rectangles. There's 1, there's 2, and there's 3. So that's 3. If I'm dividing by a half, I'm figuring out how many halves are there in that. How many halves fit into 3? You can count them, right? There's 1, 2, 3, 4, 5, 6, right? There's 6 halves that fit in there, so what was the answer to that? 6. Okay? The next one you were tackling was 2 divided by 1/4. Think about how many quarters fit into 2. That one you can actually think about money if you need to. $2. How many quarters make up $2? How many quarters does it take to fit into $2? How many quarters fit into $2? This is going to be 8. If you draw something to represent the 2, here's 1, here's another. I'm using those 2 rectangles. Actually, I'll draw them beside it. There's your 2 rectangles. How many quarters are in there? 1, 2, 3, 4, 5, 6, 7, 8, right? Have a look at the question and think about how the answer comes up here. The next thing that you looked at was 3/4 divided by 1/4. 3/4 is harder to draw, so you can draw a rectangle that is 1 like, I'll try again. We can say that's 1. So 3/4 is how much here? 3/4 is up to there. There's 3/4, right? There's the 3/4. If you're saying divided by 1/4, you're saying how many quarters fit into that 3/4? How many 1/4 fit into 3/4? You can count them. How many quarters fit in there? You can shade them in. There's 1, right? If you have 3/4 of a cookie, how many 1/4 do you have? How many quarters could you make it into if you have 3/4 of a cookie?
1.
3. You have 3/4. That's why it's called 3/4, right? There's 1, there's 2, there's 3, right? So what's the answer to this 3/4 divided by 1/4?
3/4.
It's just, no. How many 1/4 fit into this? Visualize this and visualize this. 3, right? It's just 3. It can be a circle. You can use whatever model you want. It doesn't have to be rectangles like that. If you have a circle here and you say, I have 3/4, this number. Okay, so you have all of this shaded here. Here's 3/4, all of this. And you want to divide it by 1/4. You're saying how many 1/4 fit into 3/4? How many 1/4? Well, 1, 2, 3, right? That's why it's 3. It gets more difficult when you can't directly count like that. Okay, like if you have, I don't know what your next one was that you were working on, but what was the next one you were working on? Something like 2 divided by 2/3 or something like that? Is that what you were doing? I don't know. Let's say we had 2 divided by 2/3. 2 divided by 2/3. If I'm going to draw 2 rectangles to represent the 2. Here's 1. Let's try again. There's 1, there's 2. If you're saying 2 divided by 2/3, you're trying to figure out how many 2/3 fit into that. How many 2/3 fit into that? You can just start counting by 2/3. There's 2/3. Isn't that 2/3 of the first rectangle? Right? 2/3 of that rectangle. Should I do them different colors? If I want to do another 2/3, that's only 1/3. I got to shade another one over here. Aren't those 2 green rectangles 2/3 of a rectangle together? And then what's the last one here? How many 2/3 fit into 2? How many 2/3 fit into 2? From that shaded picture there. Here's 1, here's 2, and then the other one is across there, right? What's the answer to this? How many? In other words, if you have 2 of something and you want to give 2/3 to each person, how many people can you give it to? If you have 2 pizzas and each person's going to get 2/3 of a pizza, how many people does it feed? How many?
3.
3 people, right? If you want to do division by diagrams, draw what you have and figure out how many of the other thing fit in there. The second part of that Explore the Math asks you to look at some things. It asks you to look at some of the questions you've done and to see what answers you get and look for some shortcuts. Okay? This was doing division by drawing pictures, right? You could even have something like 8/9 divided by 2/9. Let's say we were going to do that question. 8/9 divided by 2/9. If you wanted to use a diagram to model that thing, you need to first of all draw the first number, the one that you start with. If I'm going to make a rectangle and I want to be able to show 9ths, how long do I have to make the rectangle? 9, right? I should make it 9. And then 8/9 is this much, right? Let's make this big enough so we can... There's 8/9, sort of. I shaded outside of the rectangle, but that's okay. There's 8/9. If I want to divide by 2/9, how many 2/9 fit into 8/9?
4.
Yeah, you can see that already, right? There's 4 pieces, right? Each of those is 2/9. This is going to be 4. Okay? We want a shortcut. We don't always have to draw pictures for this, but it's important as a starting point to see that you can use concrete objects to do this. There's 2 ways that we're going to look for some shortcuts here. Shortcuts. Or how to do it, I guess. Method 1. Method 1, and I would copy this down somewhere, maybe after that thing you were doing, or on the other side of the page or something, or in your study guide somewhere. 1 is going to be to use a common denominator. Okay, use a common denominator. Do you notice that for this question up here, these had the same denominator? If you want to know how many 2/9 fit into 8/9, isn't that just the same as saying how many 2's fit into 8? Because if you have 8 of these things and you want to know how many 2's you can make, does it matter how long this rectangle is? Does it matter where I stopped with this rectangle? If I have 8 of something divided by 2 of something, wouldn't that be the same as if this was 11ths or something like that? What if I had 8 11ths divided by 2 11ths? What's the answer to that going to be?
4.
What's it going to be if it's 8 271sts out of 2 271st? What if this thing, so if we drag that so it was 271 parts long, what's the answer to that going to be? It's going to be 4, right? If you have 8 of these things, you want to know how many 2 fit in there, it's 4. It doesn't matter the bottom numbers. If you can make the bottom numbers the same, how can you find the answer? Just divide the top numbers. So the method here is going to be make the bottom numbers the same and divide the top numbers. Okay? So we're going to write that out here first and then we'll apply it a little more here. 1, make denominators the same. Really, you're dividing the bottom numbers as well. Really, you're saying it's 8 divided by 2 is 4, and 9 divided by 9 is 1. Really, you're just dividing the top numbers and dividing the bottom numbers. Because 4 over 1 is the same as just, what's it the same as? 4 over 1, do you have to say 4 over 1? Can't you just say 4? Make denominators the same. And then divide numerators. I'm going to say divide numerators. I'm going to put in brackets and denominators because really you're dividing the denominators as well. That's the method here, okay? Our example was 8/9. This already had the same denominator. What if we had something that was different denominators? What about if we had let's go 9/10. Not 9/10. Yeah, 9/10 works. Divided by 2/5. Okay, 9/10 divided by 2/5. That's one that's the denominator is not the same, right? How could we rewrite this question so that the denominators are the same? How could you rewrite it? Absolutely. Change that one so it's 4/10. Now this doesn't work out so nicely, does it? Because what about the top numbers here? Let's draw this one and figure this out. So you have 9/10. How long do I have to make the rectangle to represent that? 5, 6, 7, 8. How far do I have to go? 10, right? If I want to have 9/10, I can do that, right? There's 9/10. Why is this question harder than the previous one? The previous one that was 8/9 divided by 2/9. Why is this one harder? It has to do with these two numbers here. Why are those numbers not so nice? 9 and 4. Why do you think? They don't divide nicely, right? But you've done that before. You've divided 9 divided by 4 before. The answer is actually going to be whatever 9 divided by 4 is. It's going to be 9/4. That's the answer. The answer you can just write as a fraction. It's 9 divided by 4. How many of these fit in here? What is that number as a mixed number? What would this be equivalent to? 9/4, what's that the same as a mixed number? What is it? 2 and 1/4. Can we count how many of these fit into here? How many 4/10 fit into 9/10? You can start to count. Here's 4/10, right? That far would be 4/10. And there's another 4/10. How many of those have I fit in so far? How many of those have I fit in? 1, 2, and how much is left over? It's one out of, there's one, there's another, and I got 1/4 of another one, right? I have 2 of these things and 1/4 of one left over. The answer to that is 2 and 1/4, or 9/4. You can answer either way. The key is make a common denominator and then just divide the numbers. If you say 9 divided by 4, it gives you the answer. Okay? That's method 1. Here's method 2. Method 2 is to look for a rule for how you can get this. Where did this 9 end up in our answer?
On the top.
On the top. Where did the 4 end up in our answer?
On the bottom.
On the bottom. What happened to the 10s? Did it matter whether the 10s were 10s? Did it matter what the 10s were?
No.
It didn't matter, right? Because that would be, however long you make this rectangle, it doesn't matter how long you make the rectangle, it's still going to give you the same answer, 2 and 1/4, right? The 10s just disappear and cancel out. The shortcut here is, to realize that this is going to be on the bottom. Need some more space here first. If we had 9/10 divided by 4/10, this is going to be the same as saying 9/10 multiplied by 10/4. The second method is this. It's multiply by the reciprocal. Okay? This is not obvious to do this, but it makes sense once you think about it. You remember when you did 3 divided by 1/2 before? What was the answer to that? 3 divided by 1/2. How many halves fit into 3? It was 6, right? When you go 3 divided by 1/2, you're actually doing 3, instead you're doing 3 times what? 3 times 2, right? 2 is like 2/1. When you divide by 1/2, it's the same as multiplying by 2/1. if we're dividing by 4/10, it's actually going to be the same as multiplying by 10 over 4. And we already know how to multiply fractions, hopefully, from previous sections. If I want to multiply these two fractions, do you remember how you multiply two fractions? This was the easiest one, right? You multiply the top numbers, and what do you do with the bottom numbers?
Multiply.
You multiply them, right? You multiply the top, you multiply the bottom. 90 over 40. What's that the same as? 90 over 40, what's that in lowest terms?
2 and 10 over 40.
Or if we put it in lowest terms, what could it be? 9 over 4 or 2 and 1/4 or whatever, right? You get the same answer. This is a shortcut that you're going to hopefully learn, that you can multiply by what's called the reciprocal. 2 over 1 is the reciprocal of 1 over 2. 10 over 4 is the reciprocal of 4 over 10. What's the reciprocal of 3 over 7? What do you think it is?
7 over 3.
How does that work?
Y.
Well, when you did 3 divided by a half, it actually made the number bigger, right? It actually made the number larger. 6, you started with 3 and now you have 6. Multiplying by the reciprocal, dividing by a number smaller than 1 actually makes the number bigger. It's a pattern that you can, it's a pattern that is kind of a shortcut. It gets the same product. It's not intuitive to know why this works. Like, it's not something, that's why it's important to know how to do it with diagrams and stuff as well. But this is a shortcut, right? The shortcut is, if you want to do this division, you can change it to this multiplication. It would work even, like, we didn't start that question with 4/10. What was the question we started with? 9/10 divided by, wasn't it 2/5? What does this shortcut say we could do here? We could change that question to 9/10. Instead of dividing by that, we could change it to what? Multiplying by the reciprocal. What's the reciprocal of this?
5 over 3.
Okay, so one method is to change it to multiplying by the reciprocal. Instead of dividing by 2 over 5, multiplying by 5 over 2. It's hard to see why that works. As you work with it, you might start to see how it works. What would that give us? What is the top number there? 45. What's the bottom number? What is it? 10 times 2, you can do it. 20. If you reduce that to lowest terms, what would that be? What would that be? 45 over 20, can you divide them both by something?
9 over 4.
Yeah, 9/4 or 2 1/4, right? It's the same answer. Doesn't matter what you started with. You could actually get clever and do this and say, what did I have to divide both the top and the bottom by here? What did I have to divide those both by? They both could be divided by what? 45 and 20, what can you divide them both by? You can divide them both by 5, right? If you look at this question, you can see that you can divide them both by 5 by looking at the numbers on the top. You see this number is a 5 and this number is a 10. I can tell I can divide both those by 5. Instead of waiting till here, you know what you can do? You don't have to learn how to do this in grade 8, but it wouldn't be a bad idea to learn how to do this. If you see two numbers, one on the top and one on the bottom, that have something in common, you can divide them both by. You can divide it now before you work out the answer. So instead of multiplying and getting 45 over 20, you can get 9 over 4 directly if you do this and say, those two numbers can both be divided by 5. If I divide them both by 5 now, I'm going to cross them out. If I divide the 10 by 5, what do I get?
5.
If I divide it by 5, I get 2. What if I divide this number up here by 5?
1.
Now I can just go, oops, don't scribble on it. Now I can just go 9 times a 1. What does that give me?
9.
And what is the on the bottom here? The 2 times 2, what does that give me?
4.
If you want, you can do that first. You can make the numbers smaller before you make them bigger. This is a lot to kind of digest for one day, all these different methods. As you work with it, make sure you're okay with all the different methods. There's 3 things you need to know in grade 8. There's being able to use diagrams to show simpler division questions. That's number one. I guess I should have called this method 2. There is using a common denominator. If you can make something a common denominator, then you can just divide the top numbers. If you got 9/10 divided by 4/10, the answer is just 9/4. And then the third method is multiply by the reciprocal. Instead of dividing by 4/10, change it to multiplying by 10/4. Are we okay with that? I haven't done a million examples for you here. I've basically done a couple. But it's going to be up to you to go now and do the practice and finish that, the other stuff until you understand.